Good day to you all. We want to quickly take a look at this question. This is the review of the solution to the questions. And first thing we have to take a look at is we have to bring out our parameters. So we are in step one now. So the parameters we firstly brought out here is mass after 15 days. And we have another thing which is mass decayed off after 15 days. Mass after 15 days is different from mass decayed off after 15 days. So what does this simply mean? It simply means that um, after 15 days there is some remnant of the mass, and after that 15 days there have been some mass that have been decayed off before the actual remnant of the mass after 15 days. So under step one, we still have something we know as initial mass. We all know what initial mass is, which is the mass at the beginning before radioactive activities take place. Then we have our half-life. We were given our half-life, which is 5 days, and we were given our time for that initial mass to decay. The actual time they give us is 15 days. Then we move to step 2. So we input this formula. This is the general formula for activity of radioactive elements undergoing decay. So but we are talking about mass here. That's why I changed the value. So instead of having activity, I put mass of T, then is equals to mass initial. Then we have half. Then we have raised to the power of T, which is our time over the half-life. So this mass at that particular time is it is equals to mass after 15 days. So and we input our data. So we have mass after 15 days, which is what we are looking for. So because we have to look for the mass after 15 days before we look for the mass decayed off after 15 days. So mass after 15 days, which is m subscript t. Then we have our initial, we are in step 5 now. Initial mass, which is 100. Then we input our data raised to the power of 15, which is the time, then over our half-life. If we take, now moving to step 6, if we look at it, if we divide 15 by 5 in step 5, it's going to give us 3. So half raised to power 3 to the power of 3. So in step 6, if we look at the next step, we have the mass of T is equals to 100, 0.5. How do you arrive at this 0.5? 0.5 is the fraction of decimal fraction of 1/2. If you say 1/2, if you press your calculator, some scientific calculator will give you back 1/2, some will give you 0.5. So to make things easy, so you can now the power of 0.5 raised to the power 3, 0.5 raised to the power of 3. So what does this simply mean? You can put it inside your calculator, or you multiply it 0.5 times 0.5 times 0.5 in 3 places. So that leads us to step 7. Then which we have m subscript t is equals to 100. If you find 0.5 raised to the power of 3, it's going to give you 0.125. Then if you multiply 100 times 0.125, it's going to give you 12.5 gram. That is the mass after 15 days, the mass remaining after 15 days. Now what about the mass that have decayed off before getting to mass after 15 days? Then that is what leads us to step 8. So we have our initial mass minus the mass after 15 days. What's our initial mass? Our initial mass is 100 gram minus 12.5 gram. So when we have the mass decayed off, now it's now going to give us 87.5 grams. So that's how we arrive at 87.5 grams. Thanks. Please subscribe.